Welcome to the Deep Dive, your essential shortcut to understanding the biggest questions shaping our world. Every so often, a scientific announcement hits the headlines that doesn't just make waves in research labs, but sends, well, genuine shockwaves through pretty much everything.
Yeah, from boardrooms to dinner tables, real.
Exactly, from global corporations right down to, everyday families. And right now, here in August 2025, we are squarely in the middle of one of those moments. The question on everyone's mind, the one dominating conversations, market talk, social media, it's a big one. Did scientists just make gold worthless?
It's a startling question, isn't it?
It's bold, almost unbelievable. But it's precisely what we're here to unpack. In this deep dive, we're going to peel back the layers of this groundbreaking fusion reactor breakthrough. We'll explore its true, sort of multifaceted implications and really try to separate the breathless hype from the hard facts about gold's future. So if you value receiving unfiltered, real-time analysis on the stories that truly matter, the ones genuinely moving the needle in our, well, rapidly changing world, then you know what to do. Take a second right now and hit that subscribe button. It just ensures you will never miss these essential deep dives, keeps you ahead of the curve.
And that's so important here, that critical distinction between the immediate reaction, the headlines, and a deeper understanding. It's absolutely essential with this news.
Right.
When something of this magnitude breaks, especially something that hints at a fundamental shift in, well, something as universally valued as gold, you definitely see those immediate economic ripples. They're palpable.
Yeah, you can feel it.
It's a profound scientific announcement, no doubt. Pushes the boundaries of our understanding of matter itself. But its potential. Its potential to reshape global finance, influence economies, maybe even redefine wealth. It means we need to approach it not with panic, but with a clear, critical, and deeply informed mind.
Makes sense.
Understanding the underlying facts, the precise scientific achievement, and, crucially, the practical limitations. That's what empowers you, the listener, to navigate the noise and really make sense of what's happening.
Okay, let's dive right in then. Let's unpack this. The news cycle is just, it's absolutely buzzing with this story. Headlines splashed everywhere, financial news, science journals, you name it. So let's get straight to it. What exactly is the real story behind this fusion reactor breakthrough, the one that's got the whole world talking? What's the core thing we need to grasp?
Where the core achievement is, it's nothing short of extraordinary, honestly. It's a landmark moment in scientific history. Back in July 2025, a dedicated team, an international team of scientists working at a major cutting-edge facility, they announced something most people would have thought was pure fantasy.
Right. Alchemy territory.
Exactly. They successfully used a controlled fusion reactor to transmute base elements into precious metals. And yes, to be absolutely clear, that definitely included gold.
Wow, okay. And when you say a major lab, what kind of place are we talking about, just so people get a picture?
Think of places like the National Ignition Facility, NIF, in California. That's known for its huge laser-based fusion research. Or the International ITER project, the massive one being built in France, focused on magnetic confinement fusion. It's that kind of high-energy, super precisely controlled environment where this happened.
Got it. High-tech stuff.
Very much so. And the historical significance, well, it really can't be overstated. This isn't some theoretical calculation on a blackboard or a computer simulation,
No wishful thinking.
Not at all. This is the first time in history that a controlled fusion process has actually been used to create real, verifiable gold atoms in a lab setting. They produced actual gold atoms through nuclear means, in practice.
So, okay, I have to ask. What you're telling us is that, in a way, this is real alchemy, right? It feels like that ancient dream, turning lead into gold, has just jumped out of a dusty old book and into, like, a peer-reviewed journal.
It does feel like that, doesn't it?
Yeah. But you mentioned a critical scientific distinction earlier. What separates this from, the wizards in pointy hats?
You're absolutely right to make that connection to alchemy. It's natural, historically resonant. For centuries, millennia even, alchemists were obsessed with this exact quest, transmuting common metals into gold.
Right, the philosopher's stone and all that.
Precisely. And it wasn't just about wealth for many of them. Often there were deeper philosophical, even spiritual goals. They thought unlocking gold's secret would reveal fundamental truths about matter, the universe.
Okay.
So yeah, in that poetic sense, you could say we're seeing the fulfillment of an ancient dream, but, and this is the huge but, the critical distinction is entirely in the method. This is where modern science just takes a completely different path from ancient mysticism.
How so?
Ancient alchemy was based on, well, proto-science, really, mixed with esoteric beliefs, chemical experiments, ideas about earth, air, fire, water. They worked mostly with chemical processes, trying to rearrange the outer electrons of atoms.
Okay, like chemistry class.
Sort of, yeah. That can change a substance's properties, make something look different, react differently, but it can never change the core identity of the element. They couldn't turn a lead atom with its 82 protons into a gold atom with 79 protons using chemistry. Impossible.
Right. Different number of protons, different element.
Exactly. What we're seeing now, this fusion breakthrough, it's rooted deep in modern nuclear physics. It's not chemistry. It's about changing the nucleus of the atom itself. To transmute one element into another, say, a base metal near gold, into actual gold, you must change the number of protons in its nucleus.
And that takes a lot of energy.
Immense energy, almost unimaginable amounts, and incredibly precise control over subatomic forces. So, yes, it's alchemy and the outcome creating goals from something else, but it's powered by the most advanced science and engineering we have. Not medieval furnaces and symbols. It's nuclear transformation, not chemical transformation. A whole different ballgame.
That makes the distinction crystal clear.
Yeah.
Okay, so not magic, but incredibly powerful science. Let's get into that science a bit more.
For many of us, like me, turning one element into another still sounds like pure sci-fi. How does a fusion reactor actually do that? What are the mechanics? How do you force an atom to change its identity?
Okay, well, a good way to think about it is to consider the biggest alchemist we know, a star, like our sun.
Okay.
Fusion reactors basically try to mimic the conditions inside a star's core, but, here on Earth in a controlled box. At its most basic, nuclear fusion forces light atomic nuclei together under incredible heat and pressure. Millions of degrees, immense pressure.
Right, smashing atoms together.
Essentially, yes. When they fuse, they form a new, heavier nucleus, and usually a huge amount of energy is released. That's the main goal for fusion power research, clean energy.
But this experiment was different. Right. In this specific experiment, the goal wasn't just energy. It was carefully planned elemental transformation, transmutation. They took a base metal, a target element, logically something close to gold on the periodic table. Gold has 79 protons, so maybe they used a heavier version, an isotope of mercury, which has 80 protons, or thallium with 81. Those are often theoretical pathways.
Okay, so starting material matters.
Absolutely. Then they strategically bombarded this base metal target with high-energy particles. Think of these like tiny, incredibly fast bullets with immense energy. When these particles hit the target atoms hard enough, they trigger very specific nuclear reactions.
Not just bouncing off.
No, fundamentally altering the nucleus. The key is controlled nuclear reactions. It's not random. It involves adding, or in this case more likely, removing specific protons and neutrons. So if you start with mercury, 80 protons, and you manage to knock out exactly one proton through a nuclear reaction.
You're left with 79 protons.
Exactly. And an atom with 79 protons is, by definition, gold. It's a precise, incredibly energy-intensive process of re-engineering the atomic nucleus. You need the fusion reactor's power to overcome the natural repulsion between positively charged nuclei and create those extreme conditions.
So just to be absolutely clear, this has nothing in common with how we usually get gold, right?
Yeah.
You're not like cooking it up or digging it out of the ground or melting down old rings. This is fundamentally different.
Oh, completely. Light years removed from any conventional method.
Yeah.
Mining is physically extracting gold that already exists in the earth, crushing rock using chemicals to separate it out.
Yeah.
Recycling is just melting down existing gold, changing its shape, not what it is. What we're talking about here is true synthesis, the actual creation of gold atoms from atoms of a different element.
Making it from scratch, basically.
Precisely, at the nuclear level.
Yeah.
And connecting it to the bigger picture. This is pure nuclear science. Operating at the subatomic level, it needs immense energy inputs, way beyond any chemical reaction. We're talking temperatures hotter than the sun's core.
Wow.
Pressures compressing matter, like in stars. It requires cutting-edge tech, powerful lasers, superconducting magnets, ultra-high vacuum systems, all to control this tiny, super hot plasma inside the reactor. The scale, the complexity. It's totally modern, totally revolutionary. It shows we're starting to manipulate the actual building blocks of matter. Not just finding gold, but writing it into existence, atom by atom.
Okay, this is where it gets really interesting and where the practical questions just leap out. If we can make gold this way, even atom by atom, can we just scale it up, start churning it out? Are we suddenly looking at a world awash in gold? Or the big one, can we just make gold on demand now, making it worthless?
That's the absolute crux of the immediate reaction, isn't it? And the direct, honest truth is this. The process is real. Yes, they made gold atoms, but it is unequivocally not practical for any kind of large-scale production. Not even close. Not yet.
Okay, so how much are we talking?
The amount of gold produced is. Microscopic doesn't even cover it. It's infinitesimally small. We're literally talking about quantities measured in individual atoms. Maybe a few hundred, maybe a few thousand atoms in an experimental run.
Not grams, not ounces.
Oh, heavens no. Not grams, not ounces, certainly not kilograms or tons. Think about trying to pave a road with like a single handful of sand grains. The scale is just completely wrong for impacting the global supply, let alone making anything useful. It's a scientific proof of concept. It shows it can be done, but it's not a manufacturing process.
Right. And the cost. I'm guessing it's not cheap.
Astronomical is the word. The cost of just running a fusion reactor, even for a short experiment, it's staggering. These aren't machines you just plug into the wall. They need colossal amounts of energy just to get started and sustain those conditions hotter than the sun, huge magnetic fields, complex diagnostics.
Okay.
So right now, to produce even those few individual atoms of gold, the operational cost runs into the millions of dollars per experiment.
Millions for a few atoms.
Millions. Just to observe a handful of gold atoms pop into existence. Atoms that have zero commercial value because the quantity is so tiny. It's an amazing scientific feat. It demonstrates a capability, but economically, for making gold. It's light years away from viable. It's like spending $1 million to create 1 grain of rice.
Wow. Okay, that puts it in perspective, but could that change in the future?
The potential is there. Theoretically, yes. Look, the whole point of fusion energy research, the long-term dream, is clean, virtually limitless energy. If fusion technology advances to the point where it becomes dramatically cheaper, much more efficient, and critically capable of sustained energy-positive reactions.
Meaning it makes more energy than it uses.
Exactly. A Q factor well above 1 sustained. If we reach that point, then the energy needed for these transmutations would drop dramatically. You could theoretically see a day when making gold in a lab is metaphorically like printing money, because the energy cost becomes almost negligible. If the energy barrier falls away, then the constraints become reactor capacity and the availability of the starting base metals. But that day, I have to stress this, that day is not here. It's not even close. The gap between a lab demonstration and industrial scale is vast, usually decades, maybe longer. It needs huge engineering breakthroughs, massive cost reductions, major paradigm shifts.
Okay, so let's bring this down to earth a bit more. What does all this actually mean for, our wallets, for the average person? And specifically, the gold market. What's actually happening to gold prices right now, August 2025, since this news hit? Are people freaking out? Selling off?
It's been interesting to watch the market reaction, and importantly, it's definitely not a full-blown panic. Gold prices, yes, they saw a noticeable dip right after the news broke, maybe a slight wobble.
A knee-jerk reaction.
Exactly. Very typical when a headline seems to challenge a fundamental assumption about a major asset like gold. But the market has shown quite a bit of resilience. It's still holding remarkably strong, actually.
So what are the numbers looking like?
Well, checking the real-time data, from places like Kitco, Bloomberg, Reuters, gold is currently trading around, let's see, about $2,300 per ounce.
Okay. And how does that compare?
It's down a bit from the peak highs we saw earlier in the year, sure. But it is definitely not a crash. It suggests maybe a bit of caution, a reevaluation period, but crucially, not widespread alarm among serious investors.
So people aren't rushing to sell their gold bars or ETFs?
No, not in large numbers, not at all. You might see some speculative selling, short-term traders playing the volatility, maybe a few nervous individuals hitting sell. But the vast majority long-term investors, institutions, central banks, they aren't liquidating their positions en masse.
Why not, if gold can be made?
Because the dominant view among most professionals, the analysts who understand both the science and the practicalities, is that this is primarily a scientific milestone right now. An amazing proof of concept, yes, but not an imminent economic threat to gold supply or its value proposition.
Because of the tiny amounts and huge costs we just talked about.
Precisely. They recognize those profound limitations. They understand that gold's traditional value, based on rarity, history, trust, that remains largely unchanged by this specific breakthrough, at least for now. It shows the market can sometimes distinguish between a fascinating discovery and a commercially viable product. But this leads to a really interesting point. Because while the big money, the institutional players, seem relatively calm, the broader conversations, especially online, on social media, that's a whole different story. Much more colorful, much more varied.
Oh, I bet.
Which raises the question, if the institutions aren't panicking, what are people saying out there in the digital world? What are the narratives?
You just know social media is going to have an absolute field day with something like this. It's perfect fodder for hot takes, viral threads, wild speculation. What are we seeing on places like Twitter, Reddit, YouTube? Is it just chaos, or are there sensible takes too?
Oh, it's absolutely exploding. It's a swirling vortex of reactions right now, as you'd expect. On platforms like Twitter, you see a pretty stark polarization. On one side, you've got accounts, often the ones focused on grabbing headlines or quick takes, dramatically calling this the end of gold, predicting its imminent collapse as a store of value.
The gold is worthless now, crowd.
Exactly. Their logic is simple. If you can make it, it's not rare anymore, so its value disappears. They imagine this future of unlimited gold supply, stripping it of its special status.
And the other side?
Equally vocal. Dismissing it as pure hype, they point straight to the practical barriers, the crazy costs we discussed. They're saying, look, this is an academic curiosity, a cool science experiment, but it's not changing the global economy anytime soon. It's basically a digital slugfest between the tech optimists and the economic realists.
What about the big finance names, the influencers people follow for market takes?
That's particularly interesting. Prominent voices, people who've built huge followings with deep analysis. Think of Peter Schiff, who's famously pro-gold.
Right, very pro-gold.
Or someone like Lynn Alden, known for her really nuanced macroeconomic analysis. They've been quick to inject a big dose of skepticism. They're acknowledging the scientific achievement, sure, but hammering home that the practical implications for market supply are essentially zero for the foreseeable future.
So they're telling their followers, don't panic.
Pretty much. They're saying, hold your horses. This isn't what you think it is.
Yeah.
The economics just aren't there for mass production. It's a reality check.
Okay. And then there's Reddit.
Yes. Then you have the more, shall we say, irreverent corners of the internet, like Reddit's Our Wall Street Bets.
Oh, boy.
Predictably, it's a mix of humor and, underneath it, a kind of grudging acknowledgement of the science. Loads of memes, jokes about printing gold at home, building personal Fort Knoxes in their basements. It's their way of processing this huge news through satire. But even there, if you read between the lines of the jokes, the general consensus seems to be that, yeah, this won't crash the gold market overnight. Most users, despite the memes, seem to get that the immediate impact is negligible because of the practical hurdles.
Fascinating. Any really surprising takes? Anything really out there?
Well, this is where it gets truly thought-provoking. Some leading tech futurists, transhumanists, the people thinking decades, centuries ahead, they see this as way more than just a gold story.
How so?
They're suggesting this breakthrough, this ability to control nuclear transmutation with fusion. It might just be the very first tiny step towards a future where all precious metals, not just gold, but platinum, palladium, rhodium, even critical rare earth elements needed for tech could eventually be manufactured on demand.
Wow. So no more mining.
Potentially. A radical shift away from digging finite resources out of the ground in specific places. Imagine making strategic materials wherever you have the energy in the reactor.
That would change everything.
Absolutely everything. Think about wealth, power, geopolitics. If nations aren't reliant on controlling mines in certain regions for vital industrial materials, if industry isn't constrained by the scarcity of exotic materials, it shifts the whole focus from this one commodity, gold, to the fundamental concept of material abundance versus scarcity itself.
Yeah.
If we can create elements, not just find them, it could literally redefine our material economy and reshape global power structures. That's the aha moment. It's bigger than gold's price. It's about the nature of matter and value.
That is a truly powerful point. It really zooms out from just gold to, the whole idea of scarcity and our relationship with materials. So, okay, let's circle back and really hit the central provocative question of this whole deep dive head on. Could this breakthrough really make gold worthless? What's the bottom line, the nuanced take, now that we've looked at the science, the economics, the reactions?
Okay, the direct, nuanced answer, pulling together everything we've discussed, is pretty clear. Not today. Absolutely not. As things stand right here in August 2025, the process of making gold via fusion is prohibitively expensive and just astonishingly inefficient.
The millions for a few atoms thing.
Exactly. Millions of dollars for a literally microscopic quantity with zero commercial value. It is a scientific marvel, no doubt, a testament to human ingenuity, the power of physics. But economically, for making gold, it's a non-starter right now. There's no immediate threat to gold supply or its role in the economy from this discovery.
There's always a but, isn't there? The long term.
There is, and it's crucial to acknowledge the long-term potential for disruption. That's where the nuance comes in. If fusion technology advances dramatically, gets vastly cheaper, much more energy efficient, truly scalable.
The Q factor thing again. Getting more energy out than in reliably.
Right. Achieving sustained net energy gain, developing affordable, durable reactors. If all that happens, then yes, the landscape for gold could fundamentally shift in that distant future. The very value of gold could be seriously challenged down the line.
Because its value isn't just about being shiny.
Not at all. We have to remember why gold is valuable. It's partly its physical properties, sure it doesn't corrode, it's workable. But mostly, its value comes from its inherent rarity, its long history as money, and a store of value across cultures for millennia, and maybe most importantly, the trust people place in it.
Trust.
Yeah, trust. Individuals, investors, central banks, they trust it as a stable, tangible asset, a hedge against inflation, uncertainty, instability. Why? Largely because it is scarce, hard to get, and universally recognized. And crucially, because they know it can't just be created out of thin air by governments or labs, not at any meaningful scale.
Until now, potentially.
Aye.
Eventually.
Exactly. If it becomes genuinely easy to manufacture gold industrially, that bedrock of rarity just crumbles. And the deep-seated trust that underpins its value, that could be profoundly, maybe irrevocably shaken. If gold can be made from common stuff with cheap energy, that fundamental pillar of trust evaporates.
So what should gold investors do right now, hearing all this?
My practical advice,
Yeah.
stay informed. Absolutely. Keep following the science, the economics, but don't panic. Don't make impulsive decisions based on scary headlines.
Okay.
This is a significant scientific breakthrough. It pushes boundaries. But it is not right now a market crash waiting to happen or an overnight redefinition of gold's value. For the foreseeable future, gold will likely keep being valued for its traditional roles. Diversification, perceived safety. The key is distinguishing between a fascinating proof of concept and immediate commercial viability. They're often decades apart.
That's a really crucial distinction, the science potential versus the market reality today. But you're right, this feels bigger than just gold. It feels like a fundamental shift in our power over matter. So, beyond gold, what does this really mean for the future of money, wealth, society? What's the real broader impact of having this kind of power?
You've absolutely nailed the crucial point. The ripples go way beyond gold as just one commodity. If we reach a point where gold and other precious metals too can be made cheaply and efficiently, it could trigger unprecedented disruption across so many interconnected areas.
Like what? Give us some examples.
Okay, well, think about the jewelry and luxury goods industries first. Their entire model leans heavily on rarity, intrinsic material value, high cost.
Right. A diamond is expensive because it's rare, supposedly.
Exactly. If gold, platinum, even diamonds maybe become abundant, the whole luxury market has to redefine value. Maybe value shifts entirely to artistry, the designer's brand, craftsmanship, maybe the sustainability of the process, or the story behind the piece. We already see a hint of this with lab-grown diamonds, right?
Yeah, they're chemically the same but cheaper.
Right. This would be like that, but potentially for many more elements on a grander scale. Then think about central banks, national economies. This is huge.
How so?
Many countries, big players like China, Russia, even the U.S. historically, hold massive gold reserves. It's a pillar of financial stability, a tangible asset, a strategic safeguard.
Insurance against crisis.
Exactly.
Right.
If gold could suddenly be manufactured relatively easily, those colossal reserves lose their unique strategic importance. It could force a total rethink of global monetary policy, what counts as a stable reserve asset. Maybe even challenge things like the petrodollar system if traditional hedges become less relevant. Countries whose power comes from gold reserves or controlling mines, their leverage could plummet. It could really shuffle the global economic deck.
Wow. That's big.
And it would definitely accelerate a shift towards new forms of wealth. If physical metals lose that unique ultimate tangible value status, then other things become even more important. Things that are hard to replicate or constantly evolving.
Like what? Tech, data.
Exactly. Technology, intellectual property, huge amounts of actionable data, maybe even control over clean, abundant energy generation. Those could become the primary drivers of wealth and power. Imagine a world where a nation's clout isn't measured by gold and vaults, but by its computing power, its scientific breakthroughs, its renewable energy grid, its secure data networks. It fundamentally changes what we mean by resource and wealth.
Okay. And you mentioned there were things other channels aren't talking about, the uncovered story.
Right. Here's what often gets missed in the gold hype. This core breakthrough, the ability to precisely manipulate atomic nuclei using fusion. It has implications far beyond just making gold cheaper, maybe. It could enable highly efficient, maybe even customized production of new medical isotopes.
For healthcare.
Yes. Isotopes crucial for advanced diagnostics like PE scans or for targeted cancer therapies, medical imaging. Many useful isotopes now have short half-lives. They're difficult, expensive to make, limits access to treatments. Being able to create specific isotopes on demand, that could revolutionize healthcare.
That's incredible. Anything else?
Yes. It can also unlock the ability to efficiently create rare materials needed for next-gen tech. Think advanced semiconductors, the backbone of all electronics. Components for quantum computing.
Stuff we struggle to get enough of now.
Exactly. High-performance alloys for jets and spacecraft.